Hello everyone. In this video we are going to see another minimization technique which is nothing but Quine-McCluskey method. It's also called as a tabulation method. Now why do we go for tabulation method? We have few limitations in the K-map minimization technique. It is convenient as long as only the number of variables does not exceed 5 or 6 variables, because we have solved till 4 variables. We can also implement it for 5 variables and 6 variables. If it goes beyond it, it will be a bit complicated, and also almost an impossible task to simplify expression in case of a complex problem with more than 6 variables, which can be, if it is 10 variables, it will be a more complicated problem. And also this is a manual technique, and the grouping can be of a variety of combinations, so it will not be an uh, simplified expression in some cases. And also the simplification process also depends on human abilities, so the end result will not be accurate when involved with a human task. So we go for a tabulation method. First we have to sort the minterms in the binary form, this is the first step, and then we have to arrange the minterms according to the number of ones in each minterm. And the third step is we have to compare each binary number with every term in the adjacent next higher order category, and if they differ only by one bit position, put a check mark and copy the term in the next column with hyphen in the position that they differ. We have to repeat step 3 until a single cycle yields no further elimination of literals. And finally we have to list all prime implicants, and we have to select the minimum number of prime implicants which must cover all the minterms. Let's see how this works with two example problems. The first problem is this: to simplify the Boolean function with Quine-McCluskey method. The function has 9 minterms. The first step is to list all minterms in the binary form. So we can form as a table, and we have minterms 0, 2, 3, 6, 7, 8, 10, 12 and 13. And for each minterm we can have the binary representation, like for M0 it is 0000, M2 it is 0010, and so on, and for M13 it is 1101. Next step is to arrange the minterms according to number of ones. So for step 2, first we are plotting M0 which has no 1 in it, and next we have to list the minterms with single 1. So it is M2 and M8. See, for example, M2 has only 1 in it binary representation, and M8 has only 1 ones. So next is minterms with 2 ones, which is M3, M6, M10 and M12, and finally M7 and M13 has 3 ones. So the next step is we have to compare each binary number with the next order higher category. So for step 3 we can plot like this. In this, first we have to compare M0 and M2. It will be like M0 comma M2 in this column, and next we have to compare the binary representation of M0 and M2. Like for M0 it is 0000, and for M2 it is 0010. So if you see here, we have only 1 bit variation. So this 1 bit, for this particular bit location we have to put hyphen. Other 3 location can be this, it's same, so we can mention as it is. So it can be represented like 00-0 in this column. So we have to compare M0 with M8 next. So when we compare so first, before that we have to tick M0 and M2, since we have compared the terms. Next we have to compare M0 with M8. So here it will be M0 comma M8, and first the MSB is different here, so we can represent it as dash 0 0 0 like this. Next we have to compare, before that we have to tick in M8. After that we can compare, we have to compare M2 with the next higher order category, which is M3. So when we compare M2 and M3, we have the LSB bit as varying bit, different one. So we can represent it as 001 dash. So we can tick M3 here. Since M2 is already ticked, we don't want to tick it again. Next we can compare M2 and M6. It will be 0-10. So we can put a tick mark here, and then we can compare M2 and M10. It will be -010, and next we have to compare M2 and M12. For M2 it is 0010 and M12 it is 1100. Here we have more than one bit variation, so this is not eligible for carrying forward, so we are skipping this one. Next we can compare M8 and M3, which is also more than one single bit. It has more than one single bit variation, so we cannot take this. And next we have to compare M8 with M6. This also have more than single bit variation, so we have to skip this. And next we can compare M8 and M10. This has a single bit variation, so we can take it into account. So the binary representation will be 10-0. Next we can compare M8 with M12, and it is like this, and the binary representation is like this, and we can tick M12. Next we have to compare M3 and M7, which is the next higher order category. So we can take like M3, M7, and the binary value is like this. Put a tick mark here. Next we have to carry M3 and M13. It has more than single bit variation, so we are skipping this. And next we are taking M6 and M7. This has the binary form like this. And next M12 and M13 will have a final value, and this we can take. The other remaining combinations doesn't have a single bit variation, so we skipped it. So this is step 3, and step 4 is we have to repeat this cycle again. So we are forming it like this. Now we have to compare this terms with the next higher order category, which is represented in red color. So when we compare M0 M2 with M2 M3, we have 00-0 and 001-. This has doesn't have a single bit variation. It has 2 bit variation, so we cannot take this. So we are skipping this. Next we can take M0 M2 and M2 M6. This also has more than one single bit variation, so we cannot take this. Next we can take M0 and M2 M10. This also doesn't have a single bit variation, so we skip this. And the next is M0 M2 and M8 M10. This also have more than one bit variation, so we cannot take this. And finally we can take M0 M2 and M8 M10. We can group like this, and the binary representation can be like -0-0. So we can tick these two terms. So next we have to group M0 M2 and M8 M12. This doesn't have a single bit variation, so we skip this. So next we can have M0 M8 and M2 M3. This we cannot take since it has more than one bit variation. So since we go like this, these two will have a single bit variation, so we ticked it. Next category is M2 and M3, and M6 M7 will have a combination which will have a binary representation of this form. So this is ticked. The remaining terms are left as such. So we have to list the prime implicants, which is step 5. Here we have to list the prime implicants. The prime implicant is nothing but which is not ticked in step 3. So we can take this. and we have to mention its representation of variable representation and its binary equivalent binary representation, and this one M12 M13, here it is its corresponding terms. Then we have to take the midterms from step 4 also. This is it. So next step is we have to select the prime implicants. So this is step 6. We have taken all the prime implicants, and here in this column we have to fill the minterms that is given in the question. So first we have to tick the corresponding prime implicants available in the terms. For this term we have to tick M8 and M12, and for this term we have to tick M12 and M13, which is present here. And for the next one it is M0, M2, M8 and M10, and for the next one it is M2, M3, M6 and M7. So first we have to make a tick mark in the corresponding minterm. So next step is we have to see which minterm has only one tick in that corresponding column. So first in this we have only one tick, so we can take minterms present in this term. We can mark it, we can circle it here, and we can select this as a prime implicant, so we put a tick mark here. So we have to look for another or other columns with a single tick mark, which is M3. It has only one tick, so we can take all the terms in that row, or for that term we can circle it like this, and we can select it as a prime implicant. And next single tick is present in M13, and we can circle the associated or related midterms present in that terms, and we can select it as a prime implicant. So we have 3 prime implicants in this. It has covered all the midterms. See, for example, it has covered M2, M0, M3, M6, M7, M8 also covered, 10, 12, 13. All the midterms have been covered in this 3 prime implicants. So the final reduced expression is A, B, C bar, B bar, D bar and A bar, C. So we can see the next problem. This problem is with the Dont Cur terms. So all the steps remains the same. First list all midterms in the binary form. They listed here, and its binary representation. Next, step 2, arrange the midterms according to number of ones. First we have this much of midterms with only one ones, and this one with the 2 ones, and this with 3 and 4. So we have like this, and then we have to compare in each step with the next higher order category. So first we have to compare, we can have a M1 and M3. It has M1 and M3 combination with this binary representation. Next we can take like M1 and M3. Next it is M1 and M5 and the binary representation we can take. Next is M1 and M9. So it goes on like this. The step has to be repeated until complete all possible combinations. Once we make the comparison, and if it has a single bit variation, we have to put a tick mark in the corresponding midterm. So this is the most possible combinations. So So we have covered all the possible combinations. Its equivalent binary representation has been mapped. So for next step 4, we have the binary representation, and we have to go for the next cycle till no single cycle yields no further elimination of literals. So in this we have only one particular combination, M1, M3 and M9, M12, M11. This is the only possible combination that can be grouped which has a single bit variation between the terms. So next step is to have the list of tried implicants. Here we have mapped, first we have mapped 1, 3, 9, 11. Again we have got another combination which is M19 and M311, which is the same binary representation. So we have we can skip it for repetition, but we have to tick the terms in the corresponding columns. So next we have to list the prime implicants. So we can have the unticked terms in step 3 as the prime implicant with its associated term and binary representations. We can have this all 5 combinations, it seems, yes. And we can have the next these 3 sets. And finally we can have the midterm from the step 4. So next is step 6, which is we have to identify the minimum number of prime implicants which cover all the minterms. So we have listed the minterms here, and these 3 terms are don't care terms. So first we have to take the minterms present in each term. For this it is 1, 5, 2, 3, 4 and 5, 4 and 12, 8 and 9, 8 and 12, 12, 14, 11, 15 and so on. As in the previous problem, we have to first select the single tick in column, the column with a single tick, and in this case we have only one M2, the minterm M2 has a single tick, so we can circle the associated minterms with that term, and we can have a tick mark in this prime implicant M2 and M3. So all the other minterms has more than one tick. So here we have a slight modification in our procedure for this kind of problem. So we can first select, first go for minterm M1. Here we can have 2 tick. So in this case we have to select the term with maximum number of literals, maximum number of minterms present in the term. See here it has 4 minterms and here it has 2 minterms. So we have to go for this term and we can select the terms, the minterms associated with this, and we have this as a prime implicant. So this is covered, and next we can, since M2 is already marked and M3 is also already marked, we go for M5 here. For M5 we have 2 ticks in this term, and M1 M5 and M4 M5, and see here M4 is a don't care term, so we can, instead of selecting this, we have to select this term with M1 and M5. So we can cut this and we can circle this one and we can select this as a prime implicant. So M5 is marked, and next is M9. For M9 it is already ticked in this one, and also this tick has, this term has M8 and M9. M8 is an don't care term, so we can avoid this, and next we go for M12. We have 3 ticks here. See, for this term it is M4 and M12. M4 is a don't care term, so we can skip this, and this term has M8 and M12. M8 is a don't care term, so we can skip this also, and next M12 and M14, we can select this term and we can circle the associated minterms with that, and we can select this as a prime implicant. So M14 also we have selected. Next we go for M15. M15 has 2 minterms with it, 2 ticks in that column. So this M11 and M15. M11 is a don't care term, so we can skip this, and we can select M14 and 15, and we have selected this term, and we can have a tick here. So remaining 3 we can skip it since it is a don't care term, and we have to consider only the min terms that is given in the question instead of don't care terms. So the final reduced expression will be y equal to a bar c bar d, a bar b bar c, a b d bar, a b c, and b bar d bar. Thank you for watching. If you have any queries or topics that you need to learn, kindly drop a mail to the email ID or come make a comment in the video. Thank you.